Hello, Dr. Gilbert, and welcome to the Tick Bootcamp podcast.
Hello, great to be here.
Well, let's talk about first of all where you were here from. I know you're Canadian by birth, but it's my understanding that you're not in Canada any longer, at least not currently.
Oh, I haven't been in Canada for over 27 years. I live in Finland in a city called Jyväskylä.
All right. Well, welcome to our listeners from Finland and our guests from Finland. So thank you for joining us from Finland. Dr. Gilbert, why don't you first talk to us a little bit about what company you have developed and what type of work you're doing. We're going to go into your background. We're going to talk about how you got there, but I'd like to first introduce you to our community based on the entrepreneurial work that you've done and the research that you've reformed into a business that serves the Lyme disease community.
Yeah. So thank you for that introduction. And well, I'm the CEO of Tested, and our name is spelled T?TED, and the question mark is there because have you been tested? Have you been tested for Lyme disease or tested for other co-infections? So we thought we put the question mark there. And it really is a university spin-off company from the research coming out of my research group, and the research coming from my PhD students, my master's students, and generally my group from the university here in Jyväskylä. And we noticed that during some of the research projects that we had in the past, that we need to do better for the patients. So I'm always driving towards putting kind of translational value to our research, and hence why we opened Tested. So Tested is a medical device manufacturing company. And incidentally, we are actually in our facilities is here in Jyväskylä in the old Nokia research and development facility. So we kind of
Oh,
took
that's really
over and
cool.
yeah, it is. There's kind of like history there. So we're keeping the manufacturing, and the R&D, the research and development up in that area. So yeah, so we decided to do this with my previous PhD student, Kanal Garg, and him and I have been running the company, for the last, well, will be last 8 years. Our birthday is the 16th of October coming up, and we're excited to actually really still do research and development, but actually, trying to improve diagnostics for tick-borne diseases. And also for SARS-CoV-2 happens, of course, because we're a medical device manufacturing company, we rolled out a COVID test as well, antibody test, and also we also have a microtoxin test. So that is my disclosure. I am the inventors of those test kits with Canal Garg, and we obviously are shareholders in the company, but it all stems from the research group. So this is basically who I am. Yeah.
Well, thank you for sharing this with us, and please, we love entrepreneurs. We define entrepreneurs as people who are more invested in solving other people's problems than they are in solving their own problems, right? So you don't have to worry about disclosure with us. We love entrepreneurs and we love people who want to dedicate their lives and their careers to solving other people's problems. In particular, if you
Mm.
want to solve people's problems who have Lyme disease, we particularly love you on this podcast. So thank you for dedicating not only your career and your research efforts to the work that you're doing for folks in our community, but for inspiring students who you're working with to also do that work. So thank you for the disclosure, but even more importantly, thank you for dedicating your life and your career to doing this work for the sick people that we serve. Thank you.
Thank you for that. Yeah, it's my
So
pleasure to do it.
Thank you. So let's talk about your background because we want to now introduce folks to you and how you
Mm.
ultimately came to being the wonderful entrepreneur that you are, researcher and entrepreneur.
Mm.
So we did begin to share with folks that you are a Canadian, and here at Tick Bootcamp we call the Canadians the nice North Americans. So how was it to grow up in Canada, and I'm sorry, where did you grow up in Canada?
Yeah, so I grew up in Thunder Bay, Ontario. And if anybody knows the history of Thunder Bay, we have we have many, many Finnish descents, okay, in Thunder Bay. And I am not one of them, but
Well, that's interesting.
yeah, yeah, it really is. Like even still now, I believe still statistically speaking, Thunder Bay has the most Finnish population, okay, outside Sweden. So it goes Finland, Sweden, Thunder Bay. And yeah, so they came to Thunder Bay area. And like I said earlier, when we were discussing before this recording, that the geography, the forest, the million lakes, the thousand lakes that we have in Ontario is very similar here in Finland. So I'm from Thunder Bay. It is northwestern Ontario. The closest real city is like 8 hours away, Winnipeg, so it's kind of no man's land, but it's there. And when I was growing up, we didn't have such an awareness of being attentive to tick bites. But of course, I was with the Canadian military, the Navy, and we had to do tick checks all the time. And then of course, when we took kids out, camping and stuff like this, and teenagers, we always did tick checks. But Lyme disease was never back then on our mind all the time, or tick-borne diseases were not never on our mind all the time, but it is spreading, and we know it's spreading, and we're becoming more and more aware of tick-borne diseases. So
Can you give me some sense of why you were doing the tick checks if you weren't concerned about Lyme disease or tick-borne illnesses?
yeah, because some areas in Canada that we did go camping in, or that we had, excursions, actually were quite infested with ticks. Okay, and that's why we had tick checks. And I have to say, the more as the years went on, we became more and more aware that we should be, cautious about ticks. But Thunder Bay wasn't really a hotspot for ticks. And incidentally, if you look at Health Canada's website and really see where the ticks are, they have these endemic or high risk areas. And I believe Thunder Bay only became classified as this endemic or high risk area in the last maybe 5-6 years. So it's interesting that ticks are not like on the map everywhere in Canada, according to Health Canada, but there are these hot spots. And I totally disagree with that map, just like I disagree with the map in Finland too. But ticks are everywhere, and they're spreading. As we know, they're spreading because their hosts are spreading, and because of climate change, warmer temperatures, expanding the environment for these hosts, and so forth, and they carry the ticks with them. So having these hotspots, declaring that Thunder Bay is now a hotspot, that's good for my family that's still there, living there, but it's not very good, going 30 kilometers north of Thunder Bay where it's considered not a hotspot. So you will never ever get a Lyme disease diagnosis if you're bitten outside these hotspots in Canada, and that's really a pitfall in Canada. But we see that in other countries, unfortunately, too, not recognizing these hotspots, or that ticks are everywhere. So yeah.
Yeah, we have that in the US as well. Most
Mm.
folks in in the general community, and I think most folks in the medical community, believe that Lyme disease is an East Coast phenomenon. Uh,
Yeah.
and that's, I mean, it is absurd that is a thought process that still persists even in the
Mm.
medical community. But I have shared with folks on this podcast for a long time. I grew up on Long Island. I grew up in,
Mm.
in the region where the ticks were dragged, and Willie Bergdorfer examined the ticks from a community in close proximity where I've lived my entire life.
Yeah.
And the medical community is incompetent here too. I mean,
Yeah.
you would think here where the foundation is. So unfortunately, there's a lot to be done, for educating folks in governments and in the medical community. And thank God we have you to help us with that, and folks like you who are dedicating your careers to doing this work. So,
Mm.
Dr. give us some sense of how you developed a passion first for science. As a girl dad, I have 4 daughters. I'm always interested in women who have an aptitude and a passion for math and science. So I'm sorry, even in 2024, that is unique, but it is. So tell us about how you as as a girl and a young woman developed a passion for science.
That's interesting question, because I don't think I've ever been asked that. But I can, as I think, in my mind is racing here, I can think that and say this, that I come from a large family. So I have like 6 kids, and of course the parents. And we were called the Gilbert clan, the Gilbert clan. We did everything together, okay, growing up. And even our hobbies, we did everything together. And of course, as the, second youngest child, of course, I wanted to, do my own thing. We were even, I remember growing, like in grade school, in grade 4, I was with my sister Toby and Helen in the same grade. And I'm like, oh, I need to get away from my family,
The clan.
the clan, yeah. Yeah, and we were quite active. My parents was really, really great in letting us be active in many things like hobbies and so forth. And but I needed to do my own thing, and I guess I started to read novels at such a young age. Not get involved in the things that my sisters were doing, but trying to see myself doing something else. And I guess by reading more and actually just from high school, chemistry and biology and well, physics was my worst mark, but with chemistry and biology, I kind of excelled in those areas, and I thought that I would see where this leads me. And I guess that was quite different than what my talented sisters, they wanted to do, drama and sports, and so characteristically, I think genetically, we were just a little bit different, and our upbringing were the same, but we had different interests in the long run. And it drove me to, or guided me towards the science fields. And the high school was good in that I was able to be on my own in those courses, and I was able to find that certain areas I excelled in, and I found interest in. And then coming from a large family, I mean, honestly, my parents, you had to pay for education, as you know, in North America. So I had to do better in order to get a scholarship than other people, so that, I could go somewhere. And I did, and I was able to go to like a university. I did my biology, and then of course things turned differently in different paths when I actually met my husband to be there, because he was an exchange student. So you're what brought me to Finland was a question that everybody asks me, because I am Canadian, and it's love. I always say it's love. So but yeah, but uh, you know, in deciding where your path leads at such an early age, because being 19, 20 back then, and deciding, do I take this move to Finland? We tried in Canada, and unfortunately accounting laws are different in Canada than Finland, and my husband has a master's in accounting, so it was very difficult, for him to, secure a job there, because obviously the laws are different. So we had to decide what to do. And at the time, I actually had a flower shop there. I purchased the flower shop because
Oh,
in
that's
order
cool.
to, yeah, yeah. So the entrepreneurial skills, I don't know where it came from, but I know that I like the, yeah, I love the flower shop. And actually the flower shop's name was Kukakauppa, so that means, flower shop in Finnish. And I bought it
Oh,
from a
that's cool.
Finnish descent. Yeah.
And you have flowers behind you in the background that would,
I do,
yeah,
Mari Mecco flowers. Yeah.
that's,
Yeah, and yeah, and but I think the bottom line is that my relationship with my husband, brought me to Finland, and I had to do something with my life, obviously. I couldn't, start a flower shop because I didn't know the language. And so of course, what do foreigners do in Finland? Well, get an education. And I did like studying at the university in Thunder Bay, and I obviously I did like, sciences and so forth. So I wrote the entrance exam like every other Finn, okay, every other, foreigner that at that time. And back then there wasn't any courses really in this city, at least, that were offering English courses. But I wrote the exam, and I defended my exam, and I got into Helsinki University, and I also got into Jyväskylä University. But eventually I decided that I would stay in Jyväskylä, where my husband was working. And because coming to Finland, having a long distance relationship with your husband wasn't the ideal thing I wanted. So I decided to go to Jyväskylä University, and it was the biotechnology master's program that I got into. And obviously biotechnology was actually right. It brought in the entrepreneurial skills, it brought in the thinking, it brought in the, sciences, and I thought, okay, the best way to immerse myself in this, academia and this culture was to join a lab. So I joined a biotechnology lab, research lab for free, and I worked for them just to learn all my skills and everything that I could. And yeah, so that's what, brought me to this road of the sciences and so forth. So basically leaving, you know, getting away from the clan and doing something, that was passionate even back then for me. So
Well, some of it
yeah,
was leaving the clan, and some of it was finding your purpose and your aptitude, right? I mean,
yeah.
you were created to serve in a particular way with a particular type of creativity, and and you came from a multi-talented family of athletes and actors and other types of artists, and you
Mhm.
found your passion. You found your passion in two places, right? One was science, and the other was in entrepreneurship. And
Yes.
what could be more perfect than that,
Mhm.
that young girl who discovered that, now becoming the woman you are today. That's really cool
Mm.
that you shared that journey with us. So talk to us about your PhD. Where did you earn your PhD, and what was your major?
Yeah, so um, I think the common role, or the easiest role for me, I say easiest, was to, stay in Uvascula because it's still a country that, I didn't know the language. I was trying to find my footing, here in this country because, you're 22, you left your country, you left your friends, you left your, your
Not the
your
clan.
career, the
Yeah.
clan, you left everything to, you come here and you have to make a life here. So I did my master's in biotechnology under 2 years, 2.5 years. And I decided, okay, it would just be great if I could just, do my PhD. And there was a need in the group, the biotechnology group, and the my supervisor, Professor Christian Openblum, he told me that because I had a lot of teaching experience, also because I was still in the Canadian military. That's something, another life of mine. But I learned how to teach, okay, in the military, and I had such I thought I was an okay teacher, and I had some teaching skills, and my professor and supervisor got me to teach the basics in biotechnology course, and I did that. And he offered me to replace the person that was on maternity leave as the assistant of biotechnology. And the assistant of biotechnology is usually a PhD position, okay, for somebody that's going for their PhD. So I did that. I took over their course. I taught it. It was good. It was excellent. And I decided the right path was just to move me into the PhD kind of, field. So my topic was actually making biotechnological tools to investigate how canine parvovirus. Okay, so parvovirus, yeah, affects dogs quite harshly, but there's a human version as well. But I was concentrated on basically putting a green fluorescent protein outside this virus, okay, so that we could use it as a tool to investigate the life cycle of this virus inside cells, okay? And in doing that, of course, uh, led me then to really trying to get clinical perspective of what the hell I was doing. Okay, because in the PhD it was all in vitro work, it was all under the microscope, it was all, hard science, or wet science as we call it, and that was all informative and great. And but I developed a passion to learn more. And in doing so, in presenting my work at different conferences, I was looking for a place that I could actually, post PhD. Okay, so after I defended my PhD in here at University of Uvascula, what do I do? I would normally go and do a postdoc somewhere else, and I was looking for a place, and I really wanted clinical kind of aspect to what I was doing. Okay, and that's another story that you'll probably ask me, but I have to
Yes,
say,
I will.
yeah, and the clinical aspect. So of course I wanted to move towards the human parvovirus, okay, instead of the dog, but the human. And so that led me actually to Penn State University College of Medicine in Hershey, Pennsylvania, where the air smells like chocolate. Okay, it really, really, literally smells like chocolate. My apartment was 50 meters away from Reese's Pieces, factory. So,
I
so
love Hershey.
yeah, yeah, it's a great area, and I did a postdoc there, and we did human parvovirus studies there. We also did other studies and this story is going to lead to why I'm in this area. So, but to answer the question, why clinical perspective, and I have to say that unfortunately my mother had two brain aneurysms, okay,
I'm sorry.
while I was growing up, and I wanted to give her answers, okay, and she developed lupus. And I wanted to give her answers. I thought in my PhD I could probably give her some answers, okay, and also more answers if I do a postdoc that was close to, her condition and so forth. And as a woman that raised six kids, okay, she was very, this alpha female and very strong, and these aneurysms changed her, and the lupus obviously changed her. And seeing this, I really wanted to give her answers, okay, and that's why I went into the, human parvovirus area. That's why I did my postdoctoral time with, Dr. Stanley Nades, excellent, mentor. He's still my mentor and excellent researcher. And yeah, we discovered actually her aneurysms were from parvovirus, and lupus was from parvovirus. And
Wow.
yeah, this autoimmune diseases suck. And but that drove me to working under, Dr. Nades, because he is a reumatologist, and he was doing excellent work in trying to figure out how viruses could cause autoimmune conditions or chronic conditions like lupus. Okay. And that's the whole thing here, that it's, trying to give some answers, trying to help my mother understand what the doctors were telling her, trying to interpret her treatment for her, not like interpret what the doctor says that she should be doing and why she's doing it, and just putting it in a context that will help her. Okay. So that was the point. And for, 2.5 decades, we were, back and forth trying to, make sense of what was going on with her. And I have to say that's the passion. Okay. So when I did my postdoc, and it was really great, but I got involved in other smaller projects, and one of the other postdocs there was doing some studies on why certain hospital tests were not actually accurate. Okay. And so we discovered in the research with my colleague, the other postdoc, that the test kits that the hospital was using for Streptococcus pyogenes wasn't seeing the pleomorphic form, so the round ball form of that bacteria. They were seeing the rod shaped form, but not the sphere form. And that was really weird. So we presented this work, and things happened in my postdoc where Dr. Nades actually left academia, went to industry. So after a year, he says, go, take his lab, take his PhD students. And I found a place back in Uvasva, and I started bringing the research together with him, with my mentor, but also with the PhD student, that we expand on this work of why certain bacteria and viruses cause, chronic conditions. Okay. And in doing so, I was able to secure funding from a philanthropist that had really a passion in Borrelia. Okay. And back then, this was 2006, I I barely knew anything about Borrelia. Okay. But because, I was just trying to establish my own research group, I had a PhD student, we were doing parvovirus work, that was great. But I thought, okay, let's take this funding, research funding that he gave us, okay, this philanthropist, and let's investigate Borrelia. And the more and more that we got into the rabbit hole of Borrelia, and it's changing, its form, okay, it's because it's pleomorphic from a corkscrew-like structure to, a sphere, and to biofilm-like structures. I'm going, oh my goodness. So do the tests actually see these different forms? And we quickly found out that it doesn't. And so what is the utility of these forms? And our research in general, demonstrates that this is the persistent form, the sphere form. And the biofilms, of course, are in niche areas, but still it's a pleomorphic form that these tests are not testing for. So so that brought us down this huge kind of area of trying to do better for the patients, because we really demonstrated that the tests were not looking for these pleomorphic forms for Streptococcus pyogenes, for a lot of bacteria, and also then for Borrelia. And
Okay.
yes.
So there are two personal questions I have to ask you before we move on, because
Yeah.
you brought up two very important
Oh
parts of
yeah.
the background that I have to ask you about. So
Okay.
I think it's really cool that you are so multinational, Canadian, Finnish, and then coming to the U.S. to study. So and you again, just coincidentally or not, I don't believe in coincidences, but you of course landed in the state that has the largest number of Lyme disease diagnoses in the world, not just in the
Yeah.
U.S. but in the world, Pennsylvania,
Mhm.
and where you were taking your PhD. But you moved to Finland for love. How did you leave Finland to come to the US? I mean, what happened there?
Yeah, well, because usually for PhDs, they need to go and expand their skills, okay? And they should, I think, I think academically and professionally, they should gain skills, from outside their core where they were, taught. And it's quite normal for PhDs to do a postdoc, and usually they do 2 or 3 postdocs before they start a lab, okay? And that was my intent. My intent was to be away, from Finland for at least 2 years and see where it goes. But it only lasted a year, and then I quickly then started my own research lab, and yeah, so kind of that's why, because it's kind of the norm to expand, and I did expand, because my purpose was to get clinical value, a clinical perspective, human perspective of what I was doing with this, chronic infections and autoimmune conditions. So it really started, my passion of science started with this autoimmunity, like why my mother has lupus, why that she has these symptoms and so forth. And I was able to expand it. We're still doing parvovirus research. It's in our test kit. We're still doing, Borrelia research and so forth. So it's a good stem for what we're doing now. And
Yeah,
yeah, yeah.
I think that is really exciting. All right, one more piece of your background, and then we're going to move forward and talk more
Okay.
about the research you're doing. You teased us and told us a couple of times that you were in the military, but we haven't built that out yet. So talk to us about how the science geek finds herself in the military.
Yeah. Well, maybe not the science geek, maybe the clan, the member of the clan. So Canada has a great, well, we have the king now, but we had the queen back then when I was through the military. So we have 2 programs. We have the Navy League of Canada, and we also have the Sea Cadets, and then we of course we have the normal military. I became a Navy League cadet, okay, Renette, to get away from my family,
All right.
to find my own hobby. And then I became a sea cadet when I was 12 years old, and again to get away from my family. But incidentally, my sisters gave a log. My father even volunteered. Damn it! But I was the only one that stuck through it to become a military officer as 18, and I, even when I moved to Finland, I went back to Canada to be, it's called cadet instructor cadre, as we were called back then. So my job was to teach officers how to teach, and also my job was to run SAIL programs, basically, because I became a SAIL instructor as a sea cadet, and I had the passion of teaching back then, and so I carried in and did that in my master's program when I was here in Finland, because as you leave your country and go to a foreigner, you need to make money. So I made money by still serving in the Canadian Navy, doing the CIC, and teaching cadets and running the SAIL programs and teaching officers and so forth. So that was kind of like, it wasn't mandatory, it wasn't full time, but it was kind of uh, uh like maybe Girl Scouts, Boy Scouts, or guides, and but it was more because the Sea Cadet program is supported by the Canadian government, and I just became a naval officer after that. So that's my military experience. So
And it's also, of course, the foundation of your teaching experience. And one of the
yeah,
reasons why we go through the background on this podcast is because we need people to understand you and understand and learn about you, so they can step into your shoes and go on this journey with you.
yeah,
But what I love about the background piece of this podcast is it's always wonderful to see how what people would sometimes argue are coincidences, but are not coincidences, all come together and bring you to the place where you are. serving the way you are serving, where you went into the military to get away from the Klan, maybe, but the Klan wouldn't get away from you. But you learned how to teach there, and that gave you opportunities to ultimately, teach and make your way into the PhD program, which then brought you to your postdoc, which brought you to Tick endemic communities, which then allowed you to pursue your passion for seeking answers for your mother, and you were learning about I guess at least a viral connection to autoimmune disease, which of course is what Lyme disease is. And then you get, again, coincidentally, maybe the finger of God is the argument I would make. You earn a research grant, a private research grant to study Borrelia, and now here
Yeah.
we are, right?
And
So
here we are.
and here we are, which is really so exciting and so wonderful. So let's begin with some definitions, so folks
Yeah.
Can have an understanding of the larger conversation we're going to have, because one of the things we have here, Dr. Gilbert, is a whole spectrum of folks who listen to our podcast. We have some people who are just recently diagnosed with Lyme disease.
Mm.
We have some folks who are much later in the journey. We have some folks who are parents and family members and supporters of people who have Lyme disease and are new to the community. And we have some people who have some scientific background, but quite frankly, most of the people that listen to our podcast are not people with a scientific background. In fact, they're intimidated by science, and they sometimes think that they can't help themselves to heal because they don't have the scientific aptitude that you have. So we like to bring everything down to a definitional stage of this part of the podcast. Let's first talk about microbiology. You are a biotechnologist and a microbiologist. Would that be fair to describe
Sure.
you?
Sure.
Okay,
Yeah.
so let's define those terms first. What is a microbiologist?
Somebody that studies microorganisms and microorganisms in the context of bacteria, viruses, parasites, things that you really can't see with your eye that you need a microscope for.
So give us a sense of, in this community, we understand that there are different microbes that are making us sick. There are bacteria,
Mhm.
there are viruses, there are protozoa, there are mold, there are yeast, and we
Mhm.
have this whole plethora of microbes that
Mhm.
you folks study. And let's talk about how small they are, and how that was significant for you first in your research with parvo, and how you were able to use some technology to, I guess, track this virus intercellular, because they're so small they can hide. And so give us that piece of this.
Okay, so let's take a normal cell. Okay, and cells are tradition like a skin cell. They are never circular, but let's consider it being a circle shape. In diameter, that's usually about 20 micrometers in length. Okay, you can never see 20 micrometers. Okay, but let's say it's 20 micrometers. Incidentally, Borrelia, the length of Borrelia is 20 micrometers. Okay, the length. But let's look at the width. Okay, the parvovirus, the human parvovirus, is 25 nanometers. Nanometers. Okay, and and incidentally, the Borrelia width, okay, is approximately 20 nanometers. So Borrelia structure is the length of let's say, a skin cell, but very, very thin, like a hair, but very, very thin. Okay, so parvovirus is 20 nanometers in diameter. Okay, and Borrelia is that width, but the length is 20 micrometers. Okay. And in order to see anything with these things, we have to use techniques like microscopes, okay, electron microscopes, other microscopes like helium ion microscopes. But that's the whole point about my research in my PhD. We put fluorescent tags on it, like a green fluorescent protein. And incidentally, that diameter is like 5 nanometers. Okay, so we were able to put tags on the canine parvovirus to see it inside the cell. Okay, and how it gets trafficked or how it moves inside the cell. And that's the point about microbiology. Even though that they're small, we need to see them. Okay, and we use a lot of different techniques, like as I mentioned, microscopy. We can use kind of tagging techniques. We can use Western blots like we do for diagnostics for Lyme disease. there's lots of different techniques we can use, but microbiology is that to look at micrometer size kind of events, or even smaller. Okay. And like biotechnology in the strictest sense is like parvovirus would be considered, a nano organism, nanometer organism. And it is, because it's 25 nanometers, but Borrelia being 20 micrometers in length approximately, then we can't really see it with our eyes. We have to use microscopes, or we need to take it but still we can investigate it under the microscope, and inside cells and outside cells and so forth like that. So
now these things, these microbes, these bugs, are really, really small, and sometimes they're in cells and sometimes they're out of cells.
yeah.
And you're going to be, you as a microbiologist is going to study these microbes, but you can't study the microbes unless you can see them. And part of what you have to do in order to be able to see them is have the proper equipment to enhance your vision, right? But part of what you also have to do is you have to mark these microbes, because they're good at hiding, and they're good at shape shifting, and they're good at making changes, right? So why don't you talk to us about not just the enhancement of your vision with the tool, but talk about how you are now marking these microbes. I'll call them bugs as a layperson. How are you marking these bugs, and how is that helpful to you when you're enhancing your vision by using a microscope or some other tool?
Yeah, so let's take a look at the if we consider like the immune system, the human immune system, and we want to answer the question: can our immune system handle or resolve the Borrelia infection? Can
Oh,
it?
can we define that term though? What is the immune system?
Yeah, so the immune system is our system of the body that actually is the first defense to protect ourselves if we are invaded by a pathogen or a foreign microorganism. Okay, and it consists of cells. Okay, and it also consists of proteins, can be antibodies, can be cytokines, can be innately there, already established, or it can develop over time. Okay, and this is the whole premise of diagnostics that deal with the immune system, is that over time the antibodies are present and can resolve and take care of that pathogen.
Okay,
Because
let's break that down a little bit more in
sure.
lay terms. So you shared with us that there are two different elements of your immune system, right? So would you be comfortable with defining the immune system essentially as software that's going to protect us from an attack, and we have some software that we either were born with or we already possess as a result of past contact with a microbe, and then we have other software that develops a response to something that we hadn't come in contact with? Would that be a fair breakdown?
Yeah, that's a great analogy. Yes, absolutely. So innately, so we have something already set up, okay, that can recognize different patterns from pathogens, that's already there established. And that's usually is supposed to be our first defense. And then the second defense is this adaptive. So it learns once it's presented with this
In real time.
microorganism in real time. Yeah. And
Okay, so
memory, and there's memory. Okay, we do remember if we're insulted by the same, pathogen a second time or the third time or the fourth time, like in
okay,
COVID.
so bring these two pieces together now.
Yeah.
You're using that to describe, the cells and the microbes, and how does this all work together?
Well, so when we are insulted by a microorganism that will cause harm, our innate immune system, so what's already there, okay, is supposed to resolve it either by already having proteins like antibodies, or by having these professional cells that eat the pathogen, okay, or these professional cells that will pick up that microorganism, that pathogen, and present certain parts of it on the outside surface that communicates then to the adaptive, okay, immune response. And in the adaptive immune response, because the eat me cell presented certain parts of the pathogen on the outside of its surface of the cell, communicated to the adaptive side, it's giving instructions to do certain things like produce antibodies, produce, let's say, proteins or chemokines, cytokines to send out that signal again and have this kind of uh, uh, big kind of communication or a big meeting and say, hey, we have a pathogen over here. Get ready, guys. And it recruits other cells of the immune system to the site of the infection to resolve that even more. Okay. And in a normal immune system, this is supposed to be circular. It's supposed to be, very kind of efficient, all right, with the first response and the second response. And it's supposed to be efficient in the sense that it's supposed to resolve the infection. And once it resolves the infection, then of course those activated immune cells, they kind of calm down. Okay, the proteins, the cytokines, the antibodies, their half-life, they get, how do I get, they're like swept under the carpet and they get resolved. They kind of are controlled because we have helper cells in this whole circular loop that kind of resolves everything. Okay. And then, but there's memory. Okay. There are these cells, these teachers, okay, that go around circulating in our body. And if an insult of the same pathogen happens again, then this response, this circular response of the innate immune system and the adaptive, it's quicker, okay, to resolve the infection the second time. And it gets quicker and quicker and quicker. And the immune response gets more and more and more, um, the more times that we see the similar microorganism or the same pathogen. Okay, so that's memory. And this is the whole premise of vaccines, right? We get injected with parts of the pathogen, sets up this whole circular immune system with the innate and adaptive, and it establishes memory. So when we are really insulted by the pathogen, the immune spot is quicker, and we have the players in line ready to go to resolve the infection.
Okay, so we have some kind of an insult that results in microbes, germs being put into our system, and then we have a defense system that essentially eats those bugs and make sure
Mhm.
those bugs do not make us sick, right? I mean, is that really the
Yes.
the premise? All right.
Yes.
Now let's talk about how things go wrong, right? Because that's really
Yeah.
what your passion is, of course it starts with your mother and her health journey,
Yeah.
and that spurred you to utilize your gifts to understand
Mhm.
this disease process and how it can go sideways. So why don't you help us with that?
Yeah. So that in this circle, okay, I mentioned that we have these helper cells to calm everything down once the insult has been resolved. But when that doesn't happen, okay, when that checkpoint of resolution does not occur, okay, when everybody's calmed down, okay, and when all those, like, when inflammation is resolved, okay, because that's the first kind of thing in an infection, you get inflammation, right? And that's a site of recruitment of other cells to go there. When inflammation is not resolved, or when we still have these fighters trying to fight, the infection, okay, we have ourself then creating problems with our own cells. Okay. And because they're hyperactive and they have a job, and that's to kill, and to kill with a purpose. And we have these proteins circulating in our systems that causes inflammation, and they are still activated. We have cells spewing those out and creating more and more chronic inflammation. And chronic inflammation causes damage to our own cells. And because we have so much damage of our own cells, our own proteins, our own DNA gets exposed to the immune system. Okay. And our immune system accidentally thinks that that's a foreign material, and there's an immune response against our own self. And that's the premise of autoimmune disease. When these checkpoints are not put in, or well, are not working, and we start auto reacting to our own self.
So,
Yes.
Dr. Gilbert, I want to use another metaphor
Sure.
as a former military as for a member of the military. One of the things we often hear about in at least here in the U.S. is there are people who are trained to go into war zones. They go into war zones and they adapt to the war zone where they're always in a hostile environment.
Mm.
Then they come back to civilian life, and because they've become a different person, and because they've always been in this hostile environment, and they have this, kill or be killed mindset, they then sometimes come back to civilian life and they can't adjust, right?
Yeah.
They're still in that hostile
Mhm.
kill or be killed mindset, and they do not well adjust to civilian life. Many of them want to go back into the military because that was something that they became adjusted to. And as maladjusted people in civilian life, sometimes they get themselves in trouble and find themselves in a bad place. Would that be
Mhm.
a comparable comparison, where your immune system gets amped up for the war, and you have these fighter cells, and now the fighter cells don't have anyone to fight, and now
Mhm.
they're attacking your own system?
Yes, that's exactly it. Yes.
Okay, so that's the autoimmune piece, right? Where we now have
Yes.
a hyperactive immune system, right?
Mhm.
Is there another way that your immune system can become dysfunctional, not being hyperactive, but maybe hypoactive?
Yeah, of course, of course. I mean, we know that microorganisms can actually suppress the immune system in certain ways by suppressing certain immune cells, like getting, dropping those numbers down. Okay, we know that for sure. And there's lots of papers out there that, even parvovirus gets rid of, erythrocytes because that's where it multiplies, right? Babesia, red blood cells, it replicates in red blood cells, so it gets rid of red blood cells, and these people are anemic. So of course there are these infections can drop down immune players, okay, immune cells, and just because of that, of course, we don't have the numbers of those cells to do what their job should be doing. So we have hyper state of the immune system or a dysfunctional immune system. And if we put this into the context of chronic Lyme disease, because I think that's where we're going here.
We are, but can I
Yeah,
just pause that for one
yeah,
second? Because we
sure,
want to build
sure.
out a little more on definition, right?
Yeah.
So a healthy immune system is one that is balanced
Mhm.
and is responding appropriately to microbes that are somehow coming into our system, whether it be, you know, as a result of something we've eaten, or something that we've breathed in, or because of a piercing of our skin. However that happens, we have germs in our system, and our immune system, when balanced, will respond appropriately. When our immune system is out of balance, where it can be hyperactive, where it's overreactive, or hyperactive, where it's underreactive, then
Mhm.
we don't have a healthy immune system. It's out of homeostasis, or out of balance,
Mhm.
and we now have microbes that we have microbes that are not being killed that should be killed, and they're able to ultimately progress and create a disease state in us, and it could become a chronic disease state. Now, the next question I'd like to explore with you is, and I promise you we will get to the Lyme piece, but can we have an immune system that is both hyperactive and hypoactive at the same time, meaning dysfunctional in two different ways at the same time?
Yes, of course. Of course. You can have, autoimmune diseases in patients that are hyperactive. They're, creating too many antibodies against their liver, or they're, it's exactly what my mother had, but she was anemic not just because of the lupus, but she was anemic because she had, infections, other bacterial infections or other microorganism infections that actually suppressed her certain cell types like T cells or CD4 T cells that help in this communication of this immune system. So you can have both states, and that's what's so complex about the immune system, because it's not just you know black and white. Okay, there's gray states. Okay, and there's adjustments of these different cell lines, because the immune system wants to compensate and sometimes overcompensate if something's off. Okay, so it's really trying to get, like you said, so homeostasis, or a balance of all the players in line, all the proteins in line, all the elements in line of the immune system, so that it can be balanced. And it may take that we are hyperactive, in this year, or whatever, in a flare up, okay, and hyperactive in some certain immune cells, but there has to be some kind of like balance to some point in kind of normal, but what is really normal immune system. So
Right.
Yeah.
So what's happening is, in some ways, our immune system is attacking us, and in some ways, our immune system, and making us feel badly and giving us inflammation and causing us to,
Mhm.
to suffer from the horrific exhaustion that folks feel when they have Lyme disease. And in
Mhm.
some cases, it's underperforming, underreacting. It's almost like being if you had a thermostat. At the same time, if you can imagine, you could be too hot and too cold at the same time. I mean, it's
Yeah.
just unbelievable what's happening to our system as a result of these ancient microbes, right? I mean,
Mhm.
we're in a battle with ancient microbes that
Yeah.
understand us and our immune system certainly much better than we do cognitively and intellectually,
Mhm.
and they've been attacking us for millions and millions of years, right? I mean, that's
Mhm.
so now the next piece. I liked you before I even met you. And I'll admit that I'm enjoying you and our conversation more. But when I was doing the research to prepare for this podcast, I think you did an unbelievably wonderful job of describing germ theory. So can we talk about germ theory
Ah,
one moment, and some of the challenges? You actually taught me something through your work before we started having this conversation that I never thought about with germ theory before. So
yeah.
I'd like to have that part of the conversation with you, and then I promise you we'll pull it together with Lyme. Um,
Okay.
can you describe for our listeners what germ theory is and why that was such a wonderful discovery, but maybe it hasn't been as wonderful as we thought?
Yeah. So germs are those microorganisms that cause havoc in a human being or in animals, other animals. But basically, a germ causing, once it infects you, it causes one disease state. Okay. And that's the whole premise of, practicing medicine. That's the whole premise of medicine. That has been the practice, that has been the germ theory has been the premise of medicine forever. And
All right,
and
but it's become the dominant theory, right? So let's go
it
back
is.
to our high school science.
Yeah.
I don't have scientific aptitude, so that's why I need help from my professor today.
Yeah.
So Professor Gilbert, help me
Yep.
with so this is going back to Louis Pasteur. Louis Pasteur discovered that germs cause illness, or was there some other scientist that had made
Oh,
that?
yeah. I need a refresher too, but there are these like in 1549, if you can Wikipedia here. So the basic forms of gene theory was proposed in 1546. That and since then it's been really expanded by different kind of scientists like Louis Pasteur, okay, and Robert Koch. Okay, and I think what the premise of medicine nowadays is really based on the germ theory and the postulates proposed by Robert Koch, meaning that a germ, once it infects you, should be able to replicate. You should be able to isolate it from the disease organism, take it outside of the disease organism, replicate it, and actually reinfect, okay, a healthy individual and cause the same disease state. And that all there is promoting of Robert Koch's postulates, promoting this whole germ theory that it's one organism causing the disease state.
Okay. Now you're
Yeah.
getting right to where I want to. So now at the same so the dominant theory in Western medicine is one germ, one disease, and that germ could be replicated and put back into you or into another human, and of course it should create the same disease state, correct?
Yeah, and that's the whole premise
Okay.
of, yeah.
Now, at the same time that germ theory was being developed, there were
Mhm.
another group of scientists that were arguing, but unsuccessfully, that it was actually not the germ that was causing the disease state, but it was our terrain that was causing the disease state, right? And of course, that was not the dominant, certainly theory in Western medicine, that it was actually the germ and the disease, one germ, one disease, and then the terrain piece of this has largely been ignored by Western medicine. But you brought another really interesting piece to this, which is now let's bring this to Lyme, right? There seem to be two challenges with Lyme disease when the dominant theory in Western medicine is one disease, one germ, one disease, and we're not focusing on terrain at all, of course. is that in Lyme disease, when you get bitten by a tick and that tick is spitting germs into you, it's not spitting one germ into you, is it, Dr. Gilbert?
No, and it isn't. And but let's also just for a second, if I can, expand this germ theory and what it means to practice medicine, because it means like diagnostically, you're only testing for one germ, okay? And then for, clinically, you're only treating for one germ, okay? And that's the pitfall here, as you say, with these trained, healthcare providers and those scientists that are trying to promote this kind of change in paradigm of the germ theory. It's not just one organism, microorganism, it's a multitude, okay? And it's also could be your own microorganism interacting with with that pathogen as well. So it's to establish that disease state, okay? And with Lyme disease patients, and what we have demonstrated in our research is that they have an immune response against multiple microbes, okay? And it's not just against Borrelia, they don't, it's also Babesia. We call it, well, the three top ones is Babesia, yeah, Bartonella, or sorry, Borrelia, Babesia, and Bartonella. Those are the three Bs that's the top percentages of these individuals suffering from. But they're also suffering from other things too. And if you think about not just Lyme disease, but also investigate chronic Lyme disease patients, because they have been sick for so long, okay, they're susceptible to all these opportunist infections, okay, and so they're suffering from Coxsackie virus, and since they've been, because their immune system is so low, these opportunists take the time to go and you wreak havoc. They're also suffering from mycoplasma, they're suffering from other opportunist infections, and those pathogens not coming from the tick, but just because their immune system is in a dysfunction, they're more susceptible. It's like us going, for surgery at a hospital. Our immune system is just, suppressed and not in a healthy state, and we're susceptible to those opportunist infections from the hospital. It's the same thing with these, chronic patients. It's because they have, immune trauma or not a homeostasis. They're susceptible to all these other opportunist infections. But incidentally now, because of COVID time and long COVID, we're also seeing now reactivation of these, microorganisms, because the immune system is so low and the state is in trauma, and they're coming up and they're wreaking havoc. So we're seeing a reactivation of Epstein and parvovirus, and Coxsackie virus, some reactivation of other, microorganisms, and we need to be aware of that. So changing the germ theory, changing that, paradigm, it would be, let's by default start testing, not over testing, but start testing diagnostically for multiple microbes. Okay, and also then the treatment, protocols should be addressing those multiple microbes. So that's the point. Yeah.
I love the way you've described this. Was absolutely brilliant, Dr. Gilbert. Absolutely brilliant. I love the way you've described it. So now let's break it down, right? Because
Yeah.
we want to make sure that someone who does not have scientific aptitude, like yours truly, will have an understanding of all of this. I mean, absolutely brilliant description that you've given of this process, right? So one of the flaws that we have in Western medicine is we have one bug, one illness, right? It doesn't take into account, for example, with a disease like Lyme disease, where you've been bitten by a tick, and the tick is now spitting many, many microbes into you, right? Some of the research shows that there are ticks, for example, a black-legged tick, will have up to 200 microbes. Harboring up to 200 microbes. We've only identified, I think, 19 different tick diseases, and I mean, I said tick germs, and there are many that aren't even identified that are being spit into us, right? But you're now saying one of the flaws that we have in Western medicine is we're looking for one bug and one disease when we're going to have a polymicrobial infection, right? We're going to have many, many bugs coming into us. You've identified the big three. And let's talk about the big three for a minute, right? So let's talk about Borrelia, let's talk about Bartonella, and let's talk about Babesia, right? So So are all three of those microbes, which we are customarily seeing as a grouping when somebody is bitten by a tick,
Mhm.
are they all bacteria? Are some of them viruses? Or are some of them protozoa? I mean, what are we getting there in this bunch of microbes that are being spit into us?
Yeah, so as we know, Borrelia is a bacteria, Bartonella is a bacteria, but Babesia is a protozoa. So
Okay.
it's really a
So
parasite. It's like malaria, right? It's
right. So
it's
so we're not even getting one type of bug in us. We're getting a whole bunch of they're different, right? Now,
yeah,
does the immune system respond differently to
yeah.
to each one of these three? And then again, I'm this is
Yeah.
lay speak because I'm a
Hmm.
layperson. Three bugs, right? Three different types of bugs,
Hmm.
different bugs, different types of bugs.
Yeah.
Now, does your immune system respond to all three of them the same? Meaning, does it come in and eat them all at once, or do we have a different kind of response? And how is this now making it even more difficult for our immune system? Again, we're just focusing on what's been spit into us. How does it make it more difficult for our immune system to be successful in defeating these three enemies that are coming to us at the same time? It's almost like we're being invaded by Russia, China, and Iran at the same time.
Yeah, so the immune system is set up to actually handle these differently. Okay, so protozoas are treated differently, even worms are treated differently, bacteria is treating, and viruses are treated differently. And it's really all about those first players. So those players of the phagocytes are those cells that eat me, okay, cells, or they eat the pathogen, okay, and they present it and start the communication. So the communication from these different types of bugs is different. Okay, there could be some common communication, but essentially, basically, there's different communication to tell the immune system, oh, by the way, that this is a parasite. Oh, by the way, this is an intracellular bacteria, or by the way, this is an extracellular, so outside bacteria, or by the way, this is a huge, huge worm. Okay, so the communication, the talking, to recruit the different players, okay, and to recruit the different, let's say cytokines or chemokines, the proteins to resolve and to expand the communication, that communication is different. Okay. Basically, but at some point they do see similar communication, but because we don't have an infinite number of different, immune players. Okay, but we have different immune cells players that are there to handle bacteria differently than virus, than worms, protozoas. And if you think about Babesia is an intracellular, parasite, basically. Protozoas are intracellular, it's in the red blood cells. So of course it has to be treated differently than Borrelia. Borrelia is an extracellular. It does go into cells, but the point is it's seen outside, and Bartonella goes into the cell quite quickly. So again, these are different ways in which the immune system has to react. Okay.
Right. So now let's, one of the examples that someone had given in one of our past podcasts was being attacked by bees, right? And
Mm,
if you're attacked by one bee, it's not a big deal. You're attacked by two bees, it's not a big deal. But if you're swarmed with thousands of
mm,
thousands of thousands of bees, of course, what's going to happen is ultimately you're going to be overwhelmed and you're not going to be able to
yeah.
protect yourself, right? So what's happening here, of course, after this tick bite is what's happening is your system is just being overwhelmed with all these microbes coming at you, and your immune system is responding to everything differently. And now, at the same time, let's set up another piece of this because you started to address this in your broader presentation, which is we've been picking up all kinds of bugs through the course of our lives, right? You talked about Epstein-Barr and other kinds of bugs, and our body is not necessarily killing all of those bugs, but we may have them managed where they're not there. We still have these viruses in our system, and we still have these bacteria in our system. We still have, we have them in our system already, but they're being managed, right? It's part of our microbiome, right? And then what's happening is we have all these other bugs coming in, and our immune system is trying to respond to them. While our immune system is trying to respond to them, what's happening is some of those other bugs we had been managed now start to present themselves, and they now start to replicate, and they now start to make us sick. Is that accurate, or is that not an accurate description of what may be happening?
Well, I think in the context of viruses, absolutely that does happen. We know this. We don't know exactly because the science is not complete with this with Borrelia, okay, of course, or other bacteria species. But again, if we're getting the proper course of treatment, it's supposed to, with our immune system, it's supposed to, resolve, the bacterial infections that are coming from a tick, but that's not the case usually. And I would like to just mention it's not really in a healthy individual with getting a tick bite, with getting, let's say, Babesia, Bartonella, and let's say Borrelia, in a healthy individual with proper treatment, testing and treatment. Okay,
Okay,
with proper.
we have to
In
revisit the
most,
testing.
yeah, we will. In most cases, and I say most, but that's not, we know that most could be 75%. I would argue that it's 70%. In most cases, there's a resolution of these pathogens. Okay,
For
if they're
sure.
being tested for these. But in those people that are the infections are not being resolved, there's something else going on. Okay, either they're not getting the proper testing, so they're not being treated for those microbes, so that infection
Which
is
is
going
most
on and on
people.
and on, which is most people. Exactly. So it's not about like being bombarded with all these hundreds of pathogens coming from the tick. I think it's because in our hypothesis is our running hypothesis is this, that there's underlying factors in the individual, in their immune system, okay, and their microbiome, okay, and their previous insults of microbes, okay, with pathogens, that
Okay.
actually allows a fitness of if they can resolve those infections coming from a tick. And in most cases, like I said, I would give that percentage 70%. Cases, if they're treated properly, tested and treated properly, then they can resolve. But in those cases of 30% of the people or more in endemic areas or in hotspot areas, something else is going on, okay, that predisposes them that they cannot resolve these infections, okay, despite that they may be getting the proper testing, okay, meaning that they're being tested for multiple microbes, okay.
So
Okay.
let's talk about that. I don't want to
Yeah.
lose that point
Okay.
because let's talk about we've now defined the immune system and how it responds. We've defined microbes and microbiologists like you who have to be really, really smart to even conceptually understand these things that are going on that we can't see. But now we're talking about the different types of germs. What we haven't talked about is different strains of germs
Yeah. Yeah.
and how we're testing, right? So one of the flaws with germ theory is one germ, one illness. So we're only looking for
Mhm.
one germ, right? And then another flaw with testing is we're looking for one strain of one microbe. And
Yes.
we know there are, I think, there are now 23 strains of Borrelia, which we're not testing for either. So let's talk about the testing problem that we're having
Yeah.
where our tests are only looking for one thing and they're looking only for one version of one thing when we know that Lyme disease is polymicrobial.
Yeah. So it's a multifaceted kind of answer here because most of the testing that is done in North America is using the Borrelia burgdorferi senso stricto strain. Okay, senso stricto strain. And predominantly that strain is responsible for arthritic symptoms in patients. And only if those tests are negative after a period of time, okay, time, so the infection is going on, will healthcare providers entertain testing for other different strains like Borrelia apsili, Borrelia guarini, which is responsible for skin conditions or for neuroborreliosis, and that's the point that by default we could just automatically test for all three prominent strains, okay, of Borrelia, and
Of that one bacteria. We aren't even talking
yeah.
about the big three that we get in almost every time we get a tick bite, right?
Yeah, exactly. And in predominantly, why by default, let's just use those. I know in Europe though, okay, by default, the prominent testing is using the three different strains of Borrelia. And that's the Burgdorferi, sensu stricto, the Apsili, and the Guarini strains.
Okay.
Those three are in diagnostic tests here, predominantly in Europe. But in North America, it's not. And in most, like in Australia, it's not either. In a lot of countries, they're only using one strain of Borrelia, and that's the Borrelia burgdorferi sensu stricto strain. And that's unfortunate because we know and even a recent paper that came out just like 6 weeks ago, we know that there's actually 47 different strains of Borrelia.
Ah,
Okay,
well, thank you.
yeah, in the sensostricto or sensolato family group that's responsible for the umbrella of Lyme disease, 47, and they have demonstrated evolutionary pattern where some of these strains came from Europe and went to America, and then some of the strains from America came to Europe. So this misnamer of what is European strain and what is American strain, I think we need to get rid of that. And I've been saying that for a while because they're actually the strains are on both sides of the world, and genetically speaking, you can see that in demonstrated in this paper, and other scientists have demonstrated this as well, that the strains are on both sides of the world. It doesn't take any effort to put all three strains in the diagnostics, okay, test kits. So let's do it. And this is exactly what we have done. Let's do better to the patients. Let's have this by a default setting and really provide the best kind of Borrelia testing that we can.
But Dr.
But
Gilbert, it is important for us to help our listeners to understand that in many cases they will take a Lyme disease test. And again, we should talk about direct testing versus antibiotic testing and those issues as well. But they will take a test. They will be told by their practitioner, their clinician, you do not have Lyme disease, when in fact they do have Lyme disease,
yeah,
right? And the reason their practitioner is telling them that they do not have Lyme disease is because the testing that they're doing is flawed in that it's based on a flawed Western medical theory of one germ and one disease. It's one germ brings you one disease. And you've already shared with us that your research is demonstrating that a majority of people have at least 3 different types of microbes in them. But what you're also sharing with us is that the current testing is not even testing the overwhelming majority of strains of this one bacteria, Borrelia,
mm,
that would be necessary to appropriately test to help you to define what your illness is. Am I right about that?
yes, yes. And to complicate the matters, we even have health authorities say that, oh, our testing is fine. We don't need to change our testing, but they're only testing for one strain of Borrelia. But then that's the whole premise of why people say, well, our testing is so notoriously inaccurate. It's inaccurate because they're not testing for the different strains of Borrelia, and they should be by default. Okay, because these Borrelia species are maintained on both sides of the world, the different
Right.
ones.
So,
So
and we're not asking the test for 47 strains. I
no.
until just now I didn't even know there were 47. I thought there were 23. So thank you for updating me on that. But we're asking for just 3, the 3 main strains, right? But
Yeah.
what about Bartonella and Babesia, which we know is going to almost always be there together? I mean, are we testing for those as well?
Well, you see, not normally, okay, not normally, and that's the thing. If you've been bitten by the test, and they're taking statistically like a statistical approach for this, okay, because statistically speaking, Borrelia is found in at higher amounts in ticks, okay, than Babesia, and even some healthcare providers don't believe that Bartonella is actually transferred by ticks. They think it's only by the cats,
That's
okay,
correct. Yeah,
but yeah, but even still with cat scratches, I mean, it's quite high numbers, okay? So
absolutely.
statistically speaking, healthcare providers, and testing labs are going according to the guidelines, which takes the statistical approach of only testing for the prominent species and or bug that's in the tick. And that's where we need to change that, okay? And yes, but unless it's really affecting children, okay? I've just been recently in Mexico, so a little diversion here, okay? And there have been such high mortality rates of rickettsia in children in Mexico. So of course they're thinking immediately with symptoms, of course, that they're going to test for rickettsia. Okay, they're not thinking Lyme disease. They're not. They're more worried about the mortality rate of rickettsia in children. Okay, so of course the healthcare providers and the authorities, they have that on the radar that they're going to test for rickettsia. Okay, with symptoms, and also if the tick bite, and that's the thing. Statistically speaking, that plays kind of a downfall in our treatment protocol for patients because we're not diagnostically testing them for, the underrepresented, microbes or germs, and therefore the treatment is not following because we're not testing.
All right. So now let's talk about how these germs work together. Some of
Mhm.
them are trying to burn out our immune system by making our immune system overactive. Some are trying to burn out our immune system by making our immune system underactive, right? And if we're in a state where our immune system, let's say, is one or the other, and it's therefore not responding to the bugs the way it would if it were in homeostasis or your immune system was in balance. Is there a flaw in testing for antibodies? Is it possible that these bugs could be in our system, that
Mhm.
our immune system is being overwhelmed one way or the other or both, and therefore it's not responding to the particular germs that are in our system? And even if we're testing for the proper strain of the proper bug, is it possible that we're not responding and creating antibodies, and therefore the test is not going to pick up the antibodies?
Yeah, but you're describing a individual that has a anyways, a dysfunction in the immune system. Okay, so that this is what you have described to me. Okay,
Okay.
in answering this question, because obviously the immune system is dysfunction is if it's hyperactive or hypoactive. Okay, so
Correct.
in those cases, of course, we should be worried about if the antibody response against the pathogen is going to be representative of that pathogen. Of course, we should worry about that because we know in chronic patients, okay, we know that there could be a persistent IgM or persistent IgG, which is not the norm, And also we know there could be a seronegativity, so no antibodies showing up, okay, in these individuals.
Right.
And that's be really because of these individuals having an immune dysfunction, okay?
All right,
But
so
that,
let's build that out. So let's say
Mhm.
I want to make this personal. First, I'm going to
Yeah,
talk about your mom. I'm going to talk about me.
yeah,
So your mom was suffering from immune dysfunction as a result of having a virus
yep,
unrelated to a tick disease, right?
yep.
And so she had a virus that triggered an autoimmunity that was causing her immune system to not function properly. Is it possible that if she had suffered a tick bite after that, because her immune system was already compromised, that her immune system may not have responded to the microbes from the tick bite, and therefore she would not have produced antibodies that would have been testable had she been tested properly after a tick bite?
And so, of course, because her immune system is always it's dysfunctional, so it's overactive. She's have auto antibodies. Okay, but again, we got into the topic that we have different cells. Okay, in different checkpoints that should keep the immune system at a homeostasis, at a balance. So your immune system wants to do that. Okay, anyways, despite that, my mother had a autoimmune disease. Okay, it still wants to do that because
Okay.
she has been insulted with cold viruses, rotaviruses, and so forth. But of course, uh, well, unfortunately, she passed away before COVID. But if she was infected with
I'm sorry.
SARS-CoV-2, thanks. But had she have been infected with SARS-CoV-2, maybe her immune system wouldn't be as strong as it could have been to handle that. Maybe it's a possibility. So these people that have a dysfunction in their immune system may want to compensate, or maybe it just can't because it's exhausted or there's some other reason. But again, we're insulted all the time with pathogens. We are in our lifetime,
Every time we eat, right? I mean,
Yeah,
aren't we bringing
exactly.
pathogens on our food, right?
Yeah, exactly. So our immune system learns and it has memory and it tries to keep everything in balance. But in the sickest of people that have really a fundamental immune dysfunction that cannot handle an insult, like a new insult and new insult, because their immune system's getting exhausted. Okay. Then they're going to, have all these other issues. And then they cannot handle resolving those pathogens coming from, let's say, the tick bite, or they can't handle the anemia coming from a Babesia infections and so forth. And I think that's the point that we have to look at the immune status of the individual that has been infected, okay, or has been bitten by a tick, to see how they are going to resolve those tick-borne pathogens. And that's what's missing in our paradigm of medicine, is we're missing that kind of
Okay.
immune
So
fitness.
there's a perfect transition. It's exactly where I wanted to go with you. Thank
Yeah.
you. Because one problem, of course, again, and I don't want to get folks upset, but I just want them to understand the flaws in the
Yeah.
testing and how so many of them have been gaslit by their medical professionals,
Mhm.
maybe not intentionally, but because of their lack of training and their lack of testing tools. And you know
Mhm.
what clinicians want, and I know it's one of the reasons why you wanted to come into the clinical world when you were still a student. What clinicians want is they want tools that allow them to
Yeah.
understand what's wrong with you so they can treat you properly and not be sued if they do something that's outside of generally accepted medical practices, right?
Mhm.
So you know, one of the things that I think is really great about the work you're doing is that you're not only developing tests that are better for testing the microbes, but you're also developing tests to help us understand how our terrain or our immune system is functioning with that. So can you please give us that piece? Because again, it's one of the reasons I loved you before I even met you, because you get it. You know, you get it. You understand what Lyme disease, maybe better than almost anyone else I've talked to. And I want to talk a little bit more about how we define Lyme disease here. But you have to look at both pieces, right? You don't just look for one germ. You have to look for many germs. You don't look for one strain of germs. You have to look for many strains of the germs, right? But you also have to look at the terrain at the same time, because that's really where we bring these two pieces together in a way that Western medicine, at least, has not done particularly well. You're
Yeah.
doing your work is unique. I have to pay you this compliment before you describe it. Your work is unique because you're not looking for one germ. You're not looking for one strain of one germ. You're looking for many germs, but at the same time, you're looking at the response and matching those two things together. And we're not doing that in Western medicine. So help us with that, please.
So what we are researching and what we're trying to, develop is immune fitness testing. Okay.
I
And
love that.
yeah, yeah. But again, it requires more research before we can, solidify it into the clinical aspect. But the point is, there we have telltales, though, okay? And some pathogens and reactions or antibodies against these pathogens tell us about our immune state. For example, parvovirus, Coxsackie virus, and Epstein virus are those viruses that infect you as as a child or as an adult. And up to high as 85% of adults have these infections or
Absolutely.
have seen these infections. So if you are, showing antibodies against these viruses, okay, in our test kit, why? There's something going on. There's a reactivation. There's something playing a part in that. You're seeing these viruses. They're coming out of its dormant state, okay, and they're being reactivated. And that's the whole point. That gives an indication of this immune status, okay? And 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 it is truly indicative of actually the overall immune system. Because if we have viruses, protozoas, and bacteria all together, then we have a very complicated, person in respect of their immune status. And most cases, when we have immune response against these all three different types of pathogens, okay, protozoas and bacteria and viruses, most likely they're either hyperactive and leading to autoimmunity, okay, and there are some great tests to test for those, like if we see, self DNA, okay, immune response against self DNA, it's a sign of, autoimmune diseases. And also the whole point is that there's other biomarkers that we can look for too, like the CD57, which is natural killer marker, okay? If that's too low, then of course you're already set for failure because it's too low. It's not going to kill the viral infected cells. It's not going to put the immune system back into balance. So these biomarkers we can look at too. And also diagnostically speaking, some of the standard biochemistries and some of the standard biomarkers on immune cells that are standardly given out when you go in to get testing done, or just to see your fitness level of your, immune system, we can use that and forecast that if your immune status is low or dysfunction and so forth. And that's the whole point of looking at these markers, biomarkers of the immune cells, okay, and standard testing along with pathogen testing to get an overall picture of the immune system as well as then the pathogen.
Because
But
it's really the only way that you can properly assess whether or not someone, we'll go back to the example we given before, and I'll use myself as the example. I've shared with you that what motivated me to work on this passion project with my friend Matt Sabatello was I had a tick feeding on me for some window of time, and I went to my doctor's office and they were incompetent. They did not treat me no, thank God my immune system was healthy. Thank God I did not get sick. But what happened in my situation, Dr. Gilbert, was that I retained the tick that had been biting me. I put it into a plastic bag and I brought it with me to my doctor's office. I showed them the tick. Now the tick, as it turns out, I didn't know then, but I know now, was a Lone Star tick.
okay.
So a Lone Star tick does not harbor Borrelia, right? So I hand the tick to my healthcare provider. He hands it back to me and tells me I don't need to look at it. And I show him that the tick has a white spot on its back. And he said, that doesn't mean anything to us. You'll just take the antibiotics for 3 days. You'll come back for a Lyme disease test in 6 weeks. And then we'll determine if we have to do anything. By the way, my doctor's office didn't even want to schedule an appointment for me because I wasn't symptomatic at that time. So fast forward 6 weeks later, I go back for my blood test. I then get a call from the medical office telling me I do not have Lyme disease. Now, here's the problem with the scenario, right? I'm being bitten by a tick that does not harbor Borrelia.
Yeah.
I'm being tested only for one strain of Borrelia, and I'm told I'm okay. Now, I knew that was not true. My instincts were telling me that it was not true. But they didn't talk to me about testing the tick. They didn't tell me that the species of tick may or may not harbor the one bacteria they were testing me for. They didn't tell me, they didn't give me any of the information I needed to make sure that I would have a good result. Right now, a year later, we interview on this podcast a person who's running a tick testing lab, and I sent her my tick. And as it turns out, the tick had anaplasma, right? So again, whether or not that anaplasma had been spit in me or hadn't been spit in me, or whether it was still being harbored in the, I mean, we don't know any of those answers, but at least I would have had some data that would have allowed me to make a better treatment decision, right? But they were incompetent. They didn't test my immune system. They didn't give me a panel of, they didn't give me a tick panel or, a tick-borne illness panel. They did nothing. They tested one strain of one bacteria and told me that I should be on my way. Right now, I may have behaved differently if I was a different person with different concerns. Right? Whereas if we had testing tools like yours that are being developed by smart people like you, I would walk into my doctor's office, and what would happen is my doctor's office would say, okay, we're now taking out Dr. Gilbert's test. And Dr. Gilbert's test is going to do the following. By the way, I want them to tell me what the limits were of the test you had given me as well. But Dr. Gilbert's test is going to do the following. It's going to test you for 3 major microbes. And it's going to test you for the 3 main strains of microbe 1, Borrelia, and what Dr. Gilbert says is also going to do is it's going to give us markers on your immune function currently so that we know where you are, where your terrain is. And now we're going to make recommendations to you, Mr. Johannesson, that you could use over the next 6 weeks so you can properly support your immune system. And you may want to consider these antimicrobials, and you may want to, and now we have a conversation about how I put myself in a position where I get the best possible result for me.
Yeah.
That's not what we're getting, Dr. Gilbert. It's not
I
what we're getting.
I know, and it's so frustrating. And we're trying to help with this. We're
I know
trying
you are.
to.
That's why I love you.
Yeah. By the way, do you have allergy to red meat? Just
I do
thought
not. I did not. Yeah,
Okay.
I mean, again, that was another thing, right? I mean, again, I could really go off on how bad they were, right? But they didn't. For example, doctor's office say, oh, by the way, they didn't even know what the species of the tick was. I discovered that after I sent it for tick testing. Now we have other tools that we can use, right? But they didn't say to me, by the way, there's a possibility there's another type of tick in this community that is not a Lyme
Yeah.
disease tick, but it's a tick that
Yeah.
may give you alpha-gal. And, in the event that you're eating red meat and a couple of hours later, you have an allergic reaction
Yeah.
to something. I mean, nothing. I got
Yeah.
nothing.
Yeah. Yeah. I know. It's so sad. It's a similar story everywhere in the world, though. It really is. These are the challenges that the patients are facing, and
Yeah.
it's so simple to just, change the, germ theory, this paradigm, this practice of medicine. But healthcare providers want to follow the guidelines. They put them there, they are following it, and clinicians or healthcare providers want a yes no answers in their diagnostics. They want it simple, but we are not simple people. We have an immune system, we have an outlook, we're the total package. And I think we need to start thinking the total package. It's our history, it's our current state, it's our previous state. We need to start thinking that in medicine. And I think there's a lot of healthcare providers that do think this, but the majority unfortunately don't. And
Well,
it's and we have the guidelines, that are against this change of paradigm.
Well, let's talk about one more thing. You've been very generous with your time, and I know you have a social commitment that's pressing. So I apologize for. I would talk to
No
you for
worries.
3 days in a row. I would just
Yeah,
keep you on all day. So,
no worries.
let's talk about the proper definition of Lyme disease. All right, and
Okay.
I'm going to give you our Tick Boot Camp definition, which we have people sort of batting around all the time.
Yeah.
So we define Lyme disease as a polymicrobial, multisystemic, chronic and or post-chronic infectious disease. I'm sorry, chronic infectious and or post-infectious disease. What would your reaction be to that definition?
I would say that's interesting, but I would consider calling it a tick-borne disease definition, because you started polymicrobial. Lyme disease is obviously, the focus is, Borrelia, Borrelia, Borrelia. But these patients are not suffering only from Borrelia. They're suffering from tick-borne pathogens,
I
and
agree, but yeah. So
yeah,
one of the reasons why we've resisted that, I appreciate that. I
sure.
appreciate that observation. We've resisted that, even though the name of our podcast is Tick Boot Camp, right?
Yeah, yeah, yeah.
The reason we've resisted that is, at least in the community, there is the belief that there are downstream methods of contracting the disease. You can get, most folks believe you can get Lyme disease congenitally, and I think there's a lot of research supporting that.
Yeah, yeah.
So we can't necessarily call it a tick disease if it's being passed on from mother to child.
Mhm.
There are, and again, some microbes may pass the placenta, some may not, but there's certainly, a part
Mhm.
of the conversation that we are regularly having with folks in our community. There are folks that believe that it can be sexually transmitted. And I know there's some research to support that, some research that rejects that, but there is a belief in the community that is also possible, and that safe sex practices should be considered, if either you or your partner are infected, and or at least symptomatic. And then there are many folks in the community that believe at least some of these microbes can be passed on through a blood transfusion. So that we talk about the tick bite versus the downstream. So one of the reasons we've resisted just bringing the tick bite into the definition is, and we do believe that, because of the length of transmission with the tick bite and the tick spit, it's more likely that you will get sick than if you were going to get it in these other downstream methods. But we've resisted bringing that into our definition because of the downstream issues.
However, tick-borne is not really tick-borne. So it at some point has a life cycle in a tick. Okay, or you can call it vector-borne. Okay, but it
Yeah,
doesn't negate that
yes,
originally it came from,
the tick bite.
yeah, or at least a life cycle from, being in the tick. But I think, though, if we just put it into a little bit more wider context, I think we being scientists, healthcare professionals, patients, and stakeholders, need to think about really wisely what this term should be, because no matter what happens, okay, we need to be able to get, as this is another topic that can go on for hours, is an international classification of disease code, ICD code. ICD code for these diseases, okay, are what guidelines are, using. And these ICD codes are used for, as we know, to get reimbursements. ICD codes are these common language that we need. Okay, so whatever we propose as, like-minded people, we need to be able to think how to get this ICD codes. And right now, what we have is Lyme disease. Okay, and it has very different codes. Babesia has their own different codes as well. Bartonella has their own different codes. And I think that we need to get our shit together and decide what these terms were going to be, because we're not doing any favors for patients if we can't call it the same thing. And I don't think we should be at odds with one another. We need to just strategically think what is the best term to describe these patients, because we said it's a polymicrobial infection, okay? And there's different infection routes, vertical transmission, and so forth, okay? So I really think that we need to come together as a international unit, okay, and of like-minded people and stakeholders, and really decide what we're going to call this. Because a new term that came out this year that was so surprising from the National Academies of Science and Engineering and Medicine in the States: Lyme infection associated chronic illness. Oh my goodness. Do you know how confusing this is? And if we're not talking the same language, we're not doing any kind of benefits for the patients. And then unfortunately, this is going to confuse even more the community with
Yeah,
these new terms.
look, I'm with you. I mean, it is a disease without a definition. It is a disease without a test. It is a disease without a treatment philosophy that is working. I mean, we do have to wind down the podcast, because I will keep you on for more hours, and I know I can't because you have social commitments. So give us some hope here. We are the hopeful podcast, right?
Yeah.
We do want to be honest with folks, and we do want to give them a whole an outline of the spectrum of the complexity of the disease, and you've done this brilliantly. I mean, you are an unbelievably articulate scientist who can both speak the technobabble of science and break it down into very understandable terms for folks like me. So thank you very much for doing that. But part of the reason why we wanted you on this podcast is because you're the kind of person and researcher and entrepreneur, and we love entrepreneurs that are giving us hope. You are one of the people we are looking to for making the breakthroughs we think our community deserves. So thank you for doing that and giving us that hope. So give us as a way of winding down this podcast, what you think the near future is going to be for your company and the services you're going to be able to provide to us that are not currently being provided by our medical providers.
Well, we have a test with all three strains. We have a test for the persistent forms of Borrelia. We have a test for Babesia, Bartonella, all in one, and the opportunistic infections all in one, introduced in the United States. So it is emerging. It's happening now. We are in Mexico, and we have 2 labs on the go right now in the States, and you're going to see more of the name. Well, if I can say, just the name is TickPlex. Okay.
Please,
last
no. We ask, I mean,
Okay.
I know you're a scientist, and because you're a scientist, you're very sensitive with your disclosures and all that kind of stuff. That's not who we are. We want specific names, specific places, specific phone numbers. We want this information in the hands of the people who need it. So we're not asking for full disclosure. I mean, we're not asking for these, these academic disclosures of transparency. I want the information. Where can people go to get this test so they can get better results?
Okay. So we have been selling this test for the last 7 years, okay, or 8 years, and it's manufactured in Europe. It is you know, it's CE IVD marked, which is in comparison to FDA approved. It's approved here in Europe. So we have an assortment of labs in Europe already using this test, and it has been for the last 8 years. You go to our website, www.tested.com, TZTD.com, or Z in the States, TZ, and you can see our customers. Okay. And our main customer, our biggest one right now is Armin's Lab. You order the test from Armin's Lab. They will send you a blood draw kit. Okay, really fancy, really nice one. And you can order the test there. This year, in the next, let's say 4 weeks, you're going to be able to order it here in the States. Stay tuned in our website and we will promote that. And if you're at ILIDS conference in November, you can see our American customers there. And it's TickPlex Plus, which has the multiple microbes. We also have TickPlex Basic, which is just the 3 different species, and the persistent form. So we have a test kit for chronic Lyme disease because these patients have a very specific antibody response against the persistent form of Borrelia. And we have that. Yeah.
Thank you very much. This was an awesome interview, and I thank you for, and I thank your family for sharing you with us.
No,
For
thank
the
you.
time you did, and I apologize for going over time, and apologize to, please,
Okay.
to your guests for spending time with the old guy in in the US. But again, thank you for all the work you're doing, and we love you.
No,
We
thank
love the
you.
work you're doing, and we look forward to continuing to work with you. And please keep us posted on the availability of this test in the US so that we can put that
We
on our
will.
social and let other folks know. And keep, if you can, keep us on whatever email information you're sending out, because we want to continue to post that to our community. So thank you very much.
No, and thank you for having me, really. This has been incredible. So
Thank
cheers
you.
to you guys, and keep it up, guys,
Thank
really.
you. Thank you very
Yeah.
much.